Hello everyone, welcome to another Inventor tutorial. Today I'm going to show you how to design hexagonal bolt using coil command in Inventor. If you have come from SolidWorks background, you may have noticed that you need two commands to create a threaded bolt. One is sweep cut command and the other one is helix command. But in Inventor you need only one command, which is the coil command. Let's get started. Before proceed further, I would like to show you few details regarding bolt design. First one is the standard. There are different standards for different type of bolt. If you can see this table, here we have got few different type of bolt. Those are the bolts that we use our day-to-day design. Button socket head cap screw, socket head cap screw, countersunk socket head screw, Phillips pan head screw, Phillips countersunk head screw, and hexagonal head screw. I'm going to design this bolt today. So for this bolt we have got particular standards, and each and every bolt has got standards. So today we are going to discuss about DIN 933 or ISO 4017 standards. DIN is a German standard, ISO is the international standard. And this, if you look at the dimensions, those dimensions are similar. So I have highlighted here M5. M5 has got few different sizes. Minimum, S minimum 7.78, E minimum 8.79. So there are two values always represented a bolt, because bolt the dimensions can be slightly off between these two figures. And if you look at for ISO 4017, similarly minimum value is 3035, which is K equals C3035, here K equals K3035, and also S equals 7.78, here S equals 7.78. And again here we have got grade A and grade B. We have, for a bolt we have got different grades, and again remember, based on the grade, the strength of the bolt, material of the bolt, and the dimension of the bolt can be different. And here we are comparing grade A, which is the equivalent to DIN 933. This is another grade A. For this table we have got only one grade in DIN 933. That's enough for that, and let's get started. Open up a new part file, standard, click create, and first I'm going to create this hexagon. Go to home view and then select XY plane and right click, create new sketch. Go to rectangle, select polygon and create a hexagon. Let's add few relations. Click on the horizontal relations and click on this line. Now this is horizontal. And let's add S equal 7.78. I'm going to use the minimum value 7.78. And the sketch is fully defined. Now let's extrude this one by K, and I'm going to extrude this one only by 3 mm, because I'm going to have a small another protrusion to have this 0.35. Then go to 3D model, extrude and enter 3 mm, click OK. Now click on this surface and add new sketch. Click on circle and click on the center point and create a circle. Dimension the circle as 6.5 mm. which is bit smaller than the head S value and bigger than the bolt diameter. And now go to 3D model and extrude this one by 0.35 millimeter. Now if you press M, you can have the dimension shortcut key. Click on this surface, rotate, click on this surface, 3.35. Exit measure dialog box, go to home position. Click on this surface again, add another sketch, circle, click on center line. Let's make this one 5 millimeter. And again, if you measure the actual bolt diameter, M5 bolt diameter would be 4.8985 or 895. It would be between 4.8 to 4.95 actual value, but here I am making 5 millimeter. Go to 3D mode, click on this surface, click on extrude, sketch is selected. I'm going to design M5 by 10 bolt, so enter this millimeter 10 and click OK. And again, remember, when we say the length of the bolt, which is the length of the threaded area, and if you look at the bolt label, head, the shank, thread, actually this standard is fully threaded one. So bolt length of the nominal length equal to this point to up to the bottom of the head. So this M5 by bolt, that this length has to be 10 millimeter. And now we have created the bolt, and let's add a small chamfer here at this edge. Click on this chamfer. I'll make like 0.3 chamfer. Click on this edge and click apply. Alright, now the last step, I'm going to create this filleted shape on the top. In order to do that, I'm going to use extrude command. Let's see how we can do that. Click on this surface, create a new sketch, go to circle and create a circle. The diameter, make it 7.5. Make it 7.5 millimeter, which is a bit smaller than S. The S equal to 7.78. Now let's see how we can create this cut. Select middle mouse button and shift to rotate, and I'm going to go to 3D model, extrude. So this is the normal extrusion in this direction. I'm going to swap the direction to the other side, and now it has become extrude cut. And in order to create this shape, we have to go to advanced properties and make a tapered angle 60 degrees. Now you can see the shape has become like this. So it has to go further down up to this point. So I will make this one 15 millimeter. So now it's going down. Since this is an extrude cut, this whole area is cut and this part only left. If I change it to join, so there is extrusion join with the bolt. So actually we have to use intersection. When we use this Boolean operation, this will select the both common area of this cone as well as the bolt. So then we will end up having this bolt with that shape of the head. Click OK and go to home position. Now we have done most of the bolt, but final step is to create the thread. Let's see how we can do that. First of all, let's look at the profile. Let's look at the tooth profile. As I mentioned before, we are going to use coil command to create the thread. Not like in SolidWorks, we are using just one command. in Inventor to create a thread, which is coil command. So in order to use coil command, we need to create the profile first. So what type of profile we need for the thread? Let's look at different type of thread profiles. There are three main type of thread profiles that we use in our day-to-day life in the design world. The main one is isometric thread. Here you can see there are relationships between the height, the triangle height, and the pitch. Tooth height is 5h divided by 8, which is less than the triangle height usually. It is because the root and the crest are flat or curved when we create the thread. Let's look at the part of the bolt. If you look at the part of the bolt, you can see here crest and root. The root usually is flat or curved. Similarly, the crest usually flat. And here, isometric thread. This side represents external thread and this side represents internal thread. And the other type of thread profile is UTS thread, United Standard threads, and there we have got few United coarse thread, United fine thread, United is extra fine thread. So this is the other type of profiles. And the third one is Whitworth thread. This is a mainly this is used in British, in UK. And let's go ahead with matrix profiles. It is because DIN 933 and DIN ISO 4017 used matrix profiles. I have another table here that is taken from Wikipedia. You can see DIN 933 standards M1.6 to M52. M mean matrix, hexagonal cap screw, fully threaded. And currently this standard is withdrawn. That means DIN 933 is not being updated at the moment. So we have got similar standard, equivalent standard that we can use instead of 933 standard. DIN EN ISO 4017 and ISO 4017. That's enough about standards. Let's create the thread profiles. I'm going to create external thread because this is a bolt, so we have to follow this cutout. So if I maximize the cutout, the profile, you can see the relationship between pitch and the height. The triangle height equal to 0.8660 into pitch. So the height of the thread, the tooth height is 5h divided by 8, and the root width is p divided by 4, and the thread angle is 30 into 2, 60 degrees. So that's enough for the profiles. Those details are enough to create the profiles, and let's create the profile either on YZ axis or XZ axis. I will select YZ axis and right click and click on new sketch. I will orient this one the way I want, and let's use the line command and create a profile similar to the tooth profile. And now I'm going to add some relations between this top surface and this point, because I'm going to use coil command and I'm going to give height 10 mm. So when I give height 10 mm, it has to stop here. So in order to do that, I have to make this point and this point horizontal each other. When I proceed further, you will see what I really mean. So go to construction and project geometry. I will project this line and also I'll project this line. And now I will go to slice graphic so that I can see those two lines, and let's add few dimensions as well. Tooth angle 60 degrees, and let's make these two equal, and let's have this tooth height equal P into 0.88866 into 5 divided by 8, 5h divided by 8. So I'm going to add these relations. 5 into h mean 0.8660 into pitch. So I'm going to use cos pitch. So we have got fine thread pitch and cos pitch for M5. Again, these details are taken from the browser. I'm going to use cos pitch, which is again the common type of pitch for M5 bolt. So 8.8 millimeter. So I'm going to add this one, 0.8 millimeter, and divided by 8. So I divided by 8. It is because the thread height is 5h divided by 8. Click OK. Now the thread profile is dimensions properly. Need to add few relations. I'm going to drag this one and place it somewhere here, and I click on horizontal relations. I will click on this point and I'm going to click on this point. It becomes horizontal, these 2 points, and similarly click on this vertical relations, click on this point and click on this point. It is become vertical, and now I have to add the dimension of the root. The root dimension equal to pitch divided by 4. If you look at this one, you can see pitch divided by 4. So pitch is 0.8. So I'm going to have that one divided by 4. There you go. Now you have got the profiles. Let's see how we can use the coil command. I will exit this slice graphic, go to home position, and let's go to 3D model, click on coil command. There is only one unconsumed sketch profile, so which is selected by default. Now we have to use the axis. So I'm going to use axis in this direction, which is similar to Z axis. Go to model, and from this origin, from this tree, select Z axis. Now you can see the preview of the coil. Here under behavior, we have to select pitch and height. The pitch we know 0.8, and the height, the length of the bolt is 8 millimeter. 10 millimeter. There is no tapered angle, and here it has to be extrude cut because this is the cut profile, and click OK. Alright, now you can see the thread is created with given parameters. The final step, go to the gen material, let's make it stainless steel, and go to home position, save the file. And length of the bolt is always, remember, the length of this threaded area. So if you look at the bolt labeling, this is the head, shank, thread, this is the length equal to shank and threaded area. But this is the fully threaded hexagonal bolt under DI N933, so it has to be like this. I hope you have enjoyed this tutorial. If you like the video, please click on like button, and if you think my videos are useful, please hit subscribe so that you will not miss my next video. Thank you for watching.